All right, welcome everyone. This is Subtract. So the final type challenge. I gotta say, as a couple caveats specific to this video, I started this project in October of 2022. It's now May 2023, and since then, a couple new challenges have been made. That's normal. I'm not covering them in this kind of run of the series. In a few months, I have a couple people lined up that have said they're interested. I'm going to come back and we'll kind of do another round of challenges. There'll be like 10 left. And between now and then, though, I've been sort of compiling this big list of a bunch of other videos, and you'll see something on the channel about that soon. So this is the last one for now. We never missed a video. This will be airing on May 20th. So I'm very excited about that part. And we had a video every day from January 1st to May 20th. So that's big news. Today we have David. David, please tell us who you are.
Yeah, it's great to be here. I love type level coding, so it's of course a great place to be. My name is David Blass. I'm working full-time right now on developing arktype, which is this new validator for TypeScript that leverages a lot of really unique static parsing capabilities. So I've been working a lot on like type level parsing and all that sort of stuff. So very excited to be here.
That's awesome. I'm very excited to have you here. So yeah, David saved me. So as some of you have been seeing in the comments on other videos, like it's very challenging sometimes to fit in all that we're trying to do. And I had just one challenge left over and I was trying to find somebody who can hack it. This is tough stuff. And it's not everybody can like even understand. I certainly have a hard time understanding it. So I was very gracious for David to come on. Okay, so let's get to the challenge. This one is subtract. So it says implement the type subtraction. It's kind of what you would expect. We subtract, so we have in the example here two. Let's just take the challenge because that's always easier. We have subtracting 1 from 1 gives us 0. Subtracting 2 from 1 gives us 1. So we're not handling negative numbers, and we might see a solution that tries to, but subtracting 1 from 2 just returns never, and we get a type error when we have like that situation with larger numbers as well. So yeah, David, how would you go about, like, tell me your broad strokes sort of way that you would approach this?
Okay. Well, I think the typical strategy for doing this kind of math in the type system is using tuples. Mm-hmm. So to be honest, I'm definitely more familiar with like parsing and stuff like that. I have not found that many real world applications for using type level math, but it's exciting nonetheless. And I think I could probably take a stab at it. So the first thing we'll probably want is a generic. My type casing might bother you. I tend to use a lot of camel case. So, sorry ahead of time for anyone whose sensibilities that offends. But basically, I'll probably write something called construct tuple of length, and that will take in and which extends number. And I'll have a result which extends, I don't know, one array. And I will basically say that, let's see. Okay. Why am I spacing out on this real quick? That's not a.
So result is your counter, and n is that we're going to use to get the kind of.
Oh yeah, right. The stupid the length access thing. That's right. Okay.
Yes.
Yes. Okay. Right. So, okay. Result dot or index access here. Is that not giving me? Okay, it's okay. I know it's right, but I just didn't give me the autocomplete that I'm used to. Okay, result length extends n, which I guess I will actually just call this length because this is not changing at all. Oh, I can't do that either. All right.
It worked. You were renaming it? It worked on my
I tried to rename it to length. It still looks like n on my, but that's okay. It doesn't really matter. Okay, so result length extends n. Then we just want to return the result. Otherwise, we will return the destructured result and 1. So I think this will.
So sorry, it's never happened before. It's definitely there's a tear in the VS Code sync. Could you copy the constructive type tuple length thing and just paste it over what's there now, and maybe it will sync up? There we go. Okay. I have a weird thing. I'm getting an error. Okay, that's okay. I think. Does it look decent to you? Okay. All right, I'm with you so far. So we're grabbing the length.
Okay.
Okay.
Yeah. All right. So we got the tuple of length. So I think that the first step that we're going to want to do, which we could like just verify really quickly if this works, would be that we can say we want to construct a tuple of those two lengths. So just as a test, we can say like construct tuple of length m and construct tuple of length n. Okay, so now if we type subtract and we pass in, I don't know, just so we can see it, we'll try like 5 and 3 or something like that. So that didn't look very good. So it seems pretty wrong. Okay. Well,
don't we have to recurse for this to work?
Did I not? Oh geez. Yeah, this is no good. Okay, my bad on that one.
All good.
Right, there we go.
Yeah.
Okay. This should work now. I'm pretty confident.
Now it looks pretty good now.
Yeah. Okay. Well, I'm glad we took that step. All right. So I think at this point, what we'd want to do is iterate over the two. It's basically like you could, remove one element of the first tuple while you iterate over the second tuple. So like if you said then subtract tuples, and then you have A extends. We'll see if it complains with me here. A extends one array. B extends one array. It could just be unknown array. It doesn't really matter.
Yep.
But basically, so A could actually probably be used to just store the result. So we can recurse directly here. We don't need to have we don't need to store. In this case, you can see that n just stays the same. We just keep iterating until we hit the length. In this case, we don't know what the length is that we want ahead of time. So we could just say like A extends blah infer head infer tail. And if that is true, then we want to then check if B extends, which I guess it doesn't necessarily. We'll see if it matters like what order I check these in, but it probably doesn't. So B extends infer. I'll just call it B head.
Okay.
And infer.
I'll change it for you up here for A head.
Sure, I like that. Okay. Yeah, so I think then at this point, we would want to recurse.
Don't hate me. I'm formatting
what
for
happened?
you. You're good.
Okay. No, it's good. I like the formatting. Okay, so subtract tuples, and then we could pass in A tail and B tail. And then if B doesn't extend, basically doesn't have any elements in it, then we're done. And I'll actually just call this. Whatever. I guess the subtraction is fine. I guess we could say that it will return a number directly because it's so easy to just write. Because it's okay. So what do we want to write here? We just want to write A length because we're not even subtracting anything. If it's empty, it's just equivalent to 0. So we don't then care about what we've inferred. Maybe we could change the order of those because it'd be slightly more optimal for like the last element that's iterating over or whatever. But it doesn't really matter a ton. So I think if at that point, then we would return A length. And then if A, so that's the B case. And if A doesn't extend, then we've got to 0. And we already checked, let's see, in this branch, did we check whether B has any elements left? So I guess we could just check that directly instead of doing the like infer head thing. The only thing we really care about if we don't care about negative numbers, which I think that'd probably be somewhat of a straightforward way to add that going forward, because then you just start building up the array in the other direction to keep track of whether it's negative or whatever. But you could basically just say if B blank extends 0, then the result would be 0. You could write some like special case for this if you're subtracting two numbers of the same size a lot and say like if A length extends B length, then just immediately return 0. But whatever. And then otherwise, we would return never if the negative numbers case is not a big deal.
Awesome.
So yeah, maybe something like that. So let's see. So if you see subtract tuples, construct tuple of length m, and construct tuple of length s.
You're good. I got it for you.
Sorry. You'll have to maybe. I don't know what your language restrictions are, but you might have to edit me out there.
I think. Well, what happened? What did I do? Okay, 1 second. There's definitely some weird TypeScript language server problem going on. Okay, we are extremely close. It keeps telling me TSC not found. I have no idea why, but anyway, I think we're very close.
Yeah, so let's just, I mean, I can just look at these test cases. I'm probably more comfortable just saying like subtract, and I just kind of want to test it out intuitively.
Sure,
so if I just say like 5 and 3 or whatever, what do we get? Oh, 2. Okay, seems right.
Never.
Unless I'm very bad at subtraction.
Yeah, everything looks good. There's just one little error on line 38 down here.
Oh man, it's so slow. It's so weird.
Yeah, I don't know why it's doing that. I'm really sorry, but anyway.
Okay, yeah. Length, B length extends 0.
Do you see? Does it show you an error on line 36? We're having like the worst time with the language server, but so what it shows me, it says here. I'll like copy it and maybe I can put it here.
Oh, it's just the one array thing.
Yeah.
I get it. I know how this works because yeah, so I'll just write unknown array. It doesn't actually matter. TypeScript is not very good at figuring out that if you infer a head and a tail from like an array that's uniform, it should actually always be the original type. Yes. It doesn't do that. So you'd have to write. You could either write extends one array,
yes,
or you could just leave it. It doesn't really matter.
Awesome. Man, okay. You really know your stuff. Okay, yeah, perfect. And these two, I mean, we're not ever using head, so we could do that as well.
That's true. Right? We don't really care about that.
But yeah, that's just a kind of finishing touch. Well, great.
No, I like that.
You did it. I'm very impressed. I'm extremely impressed. I definitely could not have done what you just did. I'm super impressed that you just like pulled that out of the hat. So that's really super cool.
Yeah, I mean, I do like, I'm iterating over these tuples and stuff all the time. This is like my bread and butter. So I feel like it's a little bit unfair. Because for most people, it's sort of like a novelty where it's like, oh, like this is a fun thing I do in my free time when I'm not working on my job. For me, this is kind of like half of what I do is like this type of coding. So I feel like it's not exactly like, not a typical situation for sure.
I hear you. So your solution is very similar. So I have a couple to show you. I always like to show different kind of solutions and other things that people did to come up with ways to solve these problems. This one is very similar. It's a little different, but it's strikingly similar.
One array.
A lot of people do that. I don't know if you've seen, I have this thing that I came up with. I mean, I didn't totally come up with it, but I've been doing this thing on the challenges, which I think is sort of cute, which is here, I'll do them all at once. You can have the hurrah moment. Ta-da!
I did see this.
You did see it?
It was very cute. I like it.
I think it's funny. It makes me smile, and that's good enough.
No, I think it's wonderful.
So yeah, what do you tell me what you think about this solution compared to yours? I think it's got a lot in common.
It does look extremely similar. So the only thing that I noticed that could be somewhat, it looks different here at all is they compare it to 1 instead of unknown, which doesn't really matter. And it as the first element of the tuple. Yeah. And then they have a different way of approaching the 0 case, it looks like. Yep. They switched. They did the thing probably that did they do the thing that I said initially? Because I was like, oh, if we had these in the other order, we wouldn't have to do the additional check. Is this in the other order?
I think it is, yeah. Yeah, the S is first, and then the M. So you did A first and then B. They did B first and then A. Because it's subtract. Kind of makes sense, I suppose.
Oh, yes. Yes, exactly. Right. So that was kind of what I said initially, that I was like, oh, if I reverse the order of those, I think that I would skip this check. So I give this solution a slightly better grade than mine.
A gold star. So how about this one? This is teamchong. Teamchong's done many, many challenges, and we really love him here on this channel. But this is a little different.
Yes, it's pretty different. One thing that I not to be overly picky, but I will say that like in the past, I used to rely more on having these like default parameters for lots of things as like intermediate calculation stages. Yeah. I've tended to like move away from that. I don't think that TypeScript's compiler likes it as much. It doesn't work as well with caching, and it also is sometimes just messier. Like I like to split things up so that the only time that I'm really using those like default parameters is if I'm accumulating a tuple result for like one item so that it can successfully create a tail recursive calculation for that tuple size or whatever. But that stylistic nuance aside, which it's not such a big deal. Let's see what the actual like meat of the algorithm is. So, okay, so started. So this does you have a similar recursion pattern. So every time we are passing in all these parameters every time. Okay, just not the initial.
Not started.
I would 100%. I would definitely have like a root level subtract that just like takes the two parameters and then a subtract recurse or something that takes the rest of them, because it is easy to make mistakes if you pass in an extra parameter. You never want to do that here because it's literally just going to break your calculation. So yeah, I would probably, and then you can also make all the parameters required, which you want to make sure that when you're recursing, you do pass in everything. So that, I'm gonna move past that. Okay, so count length. All right, so first thing we do, diff. Okay, so we initialize them both to
nothing.
Yeah, and then we say, and then so we have this started thing, diff extends empty array, then count. Okay, okay, yeah. So that's just the start value.
Yeah, I think started is like a flag saying this is the first iteration, not some recursion.
Yeah, I feel like, okay, I get it. They're just like, I just want to do this in one go. I just want to have one type that solves it.
Yeah.
but yeah, it does make things more confusing. Okay, count length extends m, which is, okay, so that's the original number. Okay.
Yeah, I guess I didn't say in the beginning. In math, I guess there's terms for these. I don't know how to say them. Minuid and subtrahend.
Yes.
Okay. But that's why people are using M and S.
Right. Yeah. Yes, I've heard those words before, but I probably wouldn't have inferred M and S from them. But yeah, that makes sense. Sorry for using A and B.
Yeah, whatever. I would have used T and U, so I'm not any better.
Okay. Okay, so count length extends m. So that's basically the original number that is being subtracted from. And you can see there that they annotated it said from 0 to m minus 1. Yep. Okay. And then s extends started. Stop. Yeah.
Yeah, exactly. Like we're checking if they're equal, and then whether it's the first. Both times we have to check whether it's the first iteration, because on the first iteration we have to do different things. We might have to increment the diff.
I mean, okay, there's a lot of aspects of the solution that I feel like are confusing and or inefficient, because it's doing a lot of additional conditional checks that you could just get around by splitting up the type a little bit more. So I'm gonna definitely prefer the original solution, or the like previous solution. I think was a lot cleaner. Well, oh my God.
Buckle up, buddy. This is also teamchong. In the same issue, he posted this solution as well. And he said, here's a version that doesn't use tuples. I think I have an idea. He doesn't say why, but what would be your guess on why he would make one that doesn't use tuples? Any ideas? Have you hit this before?
No.
So
I don't think so.
So basically what happens is, for tuples, you hit the recursion limit when you're doing math. It specifically comes up when you're doing math, because you could be doing like the recursion limit for tuples is not that. I mean, it's less than 1,000. I don't remember exactly what it is. It's like 100, something like that. But if you're doing math, like what's an example of something you might do math for? Like, I don't know, dates or like years, calculating a year or something like that. Well, that's already in the thousands. And so sometimes if people find themselves in those situations, I think they find other ways to solve the same problem.
Yeah.
And I wasn't intending to go through every line of this one, because it's got a lot going on. I did once upon a time sit down and understand the whole thing, and then I kind of decided in the end maybe it's not worth it to go through it all. But the reason I wanted to show it is because of this table.
Cool.
It's cool. And this table at the end, this calculate map, does something interesting. So, like, this is a trick in a lot of computer science where you pre-compute things that you can pre-compute to make it easier when you do the real run. Now, usually it's like not simple arithmetic because computers are extremely optimized for simple arithmetic. So like that's actually better to just let it do it every time. But in this case with TypeScript, what he basically does is constructs all of the like addition and subtraction tables and their final values. So you see here it's 3 plus 0. And then you can use that calculate map earlier up. And you see like on line 133, for example, here, he's putting numbers that he gets together into that calculate map to see if it and then inferring digits out from that of the result, you know?
Yes, it's very cool. I like it. I hope he used the script to generate that map and didn't try to do it by hand, because that sounds pretty brutal.
Hey, multi-cursor always works. Yeah, I'm not sure.
Maybe.
I'm not sure.
I wish I was more of a VS Code wizard. There's always things that I find that I'm like, oh, this would have been such a nice solution to this problem that I was working on. I think it's cool, and I'm very partial to like this kind of stuff because, like I said, I do a lot of string parsing, and there's like obviously very cool, powerful things you can do with this kind of approach. I mean, even for example, like in arktype, there's a lot to do with parsing like numbers and big ints and turning them into literals. And we even have additional checks that say like, oh, well, if we turn it into a literal, but it wasn't like a narrowed number, then we give like a type error. So there's like a lot of cool stuff you can do with this kind of like number parsing stuff. And of course, the classic trick of like, is this string an integer? You can check if it extends like the stringified version of big int, which I think is very nice. Yeah, I mean, if I were TypeScript, I mean, I don't know. I think the way I've always, well, maybe it's not TypeScript, it's JavaScript, but the way that JavaScript stringifies a big int does not include the like n suffix that's in the literal, which I'm
You're talking about this?
Yes, yeah, I use that quite a lot. Things like that.
That's so amazing. People who have been watching the videos are really tired of hearing me say it, but I think that this is literally my favorite solution to any type challenge. I think this is so clever. Just what you were just saying. I think this is so just. I mean, it's just so cool.
It's very elegant. Yeah. And so basically the additional like check that we sort of add here is so then we would say like if big int well, okay, so I guess since we need to know the specific value, so like let's say we're trying to parse like an integer or literal, right? So we'd say so if t extends infer value extends big int, and then we would say big int extends value, then it would be like, appeared to be an integer, but couldn't narrow correctly, try removing leading zeros, leading or like trailing zeros and things like that, because that's what causes TypeScript to like call it a big int, but then it won't actually infer a literal from it. It has to be like a one-to-one mapping where TypeScript will only ever have like one representation of a big int that can stringify and be parsed in both directions. And then otherwise, as long as it did narrow, then would like return the initial value, which hopefully that's the correct number of conditional checks. But yes, like something like that, I feel like is a very useful tool.
We're geeking out, and I just like cannot resist. I want to show you like my second favorite type challenge. So this is not it. This is to primitive. So just like taking in a type and returning the primitive like that you might get. So this could happen if you get like a literal, if you passed in x to primitive, you have a thing here and you just want to turn it into its primitive type. In this case would be string.
Yeah.
Somebody, there's this person, and they've commented on the challenges, which I thought on the videos, which I thought was really interesting. They came up with this solution.
Wow.
Isn't that something?
It's impressive that works, honestly.
Isn't it?
It's very cool. Yeah.
Isn't this so cool? It's like the amount of four-dimensional thinking required to come up with a solution like that is just so beautiful to me. I don't know. I would never be able to.
Yeah. Well, and the fact that TypeScript
can do that.
Actually does it correctly, I think is always impressive. Or like, all the tuple map stuff definitely relies on TypeScript being very cooperative with like being able to access length of a tuple as an actual narrowed number literal, which is a nice thing that it does. One thought that I have, which like I'm not 100% sure this is true for like all of the subtraction stuff, but I know that you. Okay, sorry.
No, it's okay. I thought you were stopping. Go on. Yeah, forget this for a second. Go on. What were you saying?
So one thought that I had was, so I know that like you can hit recursion limits pretty easily, but I wonder like if you look at the solution that I wrote, which like we can take another look at that. Okay. Because I actually don't remember. It's somewhere near the top there. It's like this.
Yep.
I'll just let you uncomment that. Yep. So basically, I think that if we had like a result, so like in this case, right, you should be able to construct like a very, very large tuple, I believe, and like will not hit any kind of recursion limit, specifically because we have like one branch of the conditional that returns this original type, which is a parameter here. So it's like optimized for tail recursion, so it doesn't store any of the intermediate calculations. So like I think that if you wrote like, and maybe I'll be shown to be wrong here, but if you say construct tuple of length and you just say like 1,000 or 10,000 or something like that, and it might say this TypeScript server, I don't know what to make of it.
Something's weird. Yeah, it's never happened before, so I don't know. Life as a Linux user, I guess these kinds of things go on, but
it's rough. Yeah, I think that this works normally in like a standard environment. I'm fairly sure, but I could be wrong. But like I'm pretty sure that basically it's just like if you have one of your parameters that is like nakedly returned as like the final outcome in one branch of your conditional, then that allows it to optimize away all the intermediate calls, so it doesn't count towards your recursion limit. I think you could, so we don't have that implemented that way right now for subtract tuples, but we could rewrite it pretty easily to have like a result accumulator here, and then we could use the same approach. And then I think, not to say that all the integer parsing stuff isn't cool, but I think you could use this and then not hit the recursion limit.
I just tried it on the playground, and it gave me this guy. The type instantiation is excessively deep and possibly infinite.
Yeah.
So
I think there should be a way to do it. But perhaps I would have to mess around with it a little bit. Maybe. Yeah, that's a hop in the playground.
Yeah, it's this is a thing about TypeScript that I think is a little elusive because it's kind of hard to know. I feel like I've hit situations where it's a much higher limit, and then I've also hit situations where it feels lower than even what they state. I wanted to show you, if you scroll down to the very bottom, I'll show you one more. I thought this one was kind of interesting because it's the shortest solution. It passes the tests. This part here, to array, is we've seen, I think that was exactly the same as your construct tuple guy that you made.
Oh, this is great. This is the best one. I like this the best.
Yeah, tell me. Yeah, you tell me what you think about it.
Well, I mean, it used some similar strategies to some of the stuff we were using, but it just made the optimization right away that it could just basically rely on TypeScript inference capabilities to say, like, hey, how many additional elements do I need to add on to this base number to get to add on to the subtrahend to get the minuend, right? Mm-hmm. And just like infer all of those elements, which I think is very elegant. Yeah, this is my favorite solution for sure.
This is super clever. Yeah, so I just think it's so interesting, like these kind of little tricks, and you can see how many are left over. And, there would be none left over. One of the things that I think, my explanation, we were talking a little earlier about how sometimes you have to say like extends one, you have to put some kind of kind of type refining in there.
Yeah. My
kind of thought pattern on part of why that is that if you have the last recursion, if you're thinking about the last recursion of the, last recursion, the thing at the end would be this. It would be empty tuple, which an empty tuple is not compatible with a tuple of some value. Like it's not compatible with like a one array or a counter array or whatever. So that to me was like my explanation but that doesn't explain why in the first case. I guess if you pass in an empty tuple outright, then there would be nothing for, I don't know. Anyway, that's something I would like to understand better about TypeScript.
Oh, well, okay. I mean, I think so basically like if you think about sort of what's going on here, if you think about it in terms of like a series of like a one array, right? Mm-hmm. So you're basically telling TypeScript something like, okay, so say it's like 7 minus 5, right? So you'll say like 7 ones extends, and then this would be 5 ones. And then you tell TypeScript, infer whatever I need to add on to 5 ones to get 7 ones. So it should say, oh, if I destructure 2 ones, then I should get 7, right? So, I mean, I think the coolest thing about this is that obviously it still has to recurse in order to create the initial arrays, but this doesn't have to recurse directly at all to actually do the subtraction, which is like, that's what makes it such a much better solution, in my opinion.
Yeah. Okay, awesome. I think I better get it now. Well, all the same, David, thank you so much for coming on. As a teaser to everyone, David and I may or may not be getting together in the future to talk about arktype, but you'll hear more about that as it comes on the channel. And yeah, thanks for being a part of the journey with the type challenges. I really appreciate it.
Yeah, it was a lot of fun. And feel free to, hit me up anytime if you need some slots filled or something like that. I'd love to take on some more of these challenges, and excited if we have that opportunity to catch up on arktype soon.
Awesome. All right. Bye, everyone. Thank you very much for watching.